Hi, we are now looking at chapter 5, and this is about trigonometric functions. And in this chapter we are going to look at the trigonometric function from a unit circle point of view. There is another view or another approach for trigonometric function, which is called the right triangle approach. So we will work with that in a later chapter. So first, what is the unit circle? Well, I hope everyone knows what a circle is. A unit circle is a circle which has unit length, means length of 1. It could be 1 centimeter, it could be 1 inch, it could be 1 meter, it could be any unit of length. So radius is 1 unit, and then its center must be at the origin. So if you see a circle, just like a circle drawn anywhere, but it's not and is of radius 1, then that is not a unit circle. The unit circle must be drawn with its origin at the center. Now you can see that the unit circle crosses the x and the y axes, and so this is crossing at 1. What are the coordinates of this point? It will be 1, 0. Then it is crossing the y axis over here, so the y coordinate is 1, the x coordinate will be 0. So the coordinate of this point are 0, 1. And here, so this will be negative 1, and the y coordinate will be 0. So x coordinate is negative 1, and this is something I hope everyone knows. What are the coordinates of these points? So what about this one? Here the y coordinate is negative 1 and the x coordinate is 0. So we have 0, negative 1. So you must know these points, the coordinates of these points. Now the equation of the unit circle is x square plus y square is equal to 1. Why? Because the equation of a circle which has a radius of a units and its center is at origin is given by x square plus y square is equal to a square. Now in our case a is 1, so we have the equation of the unit circle is x square plus y square is equal to 1. Now the unit circle, actually these axes, when we draw these axes, x and y axes, you notice that the whole plane is divided into 4 regions. So we this one here where x has positive value, so is over here x is greater than 0, on this side x is less than 0, over here y is greater than 0, and over here y is less than 0. So here y is greater than 0, and over here y is less than 0. Y is negative. Okay, so what happens then, because if you notice this piece, and so this first quadrant or quadrant 1 is it is made by the positive x-axis and the positive y-axis. So all points over here will have the both coordinates positive. The second quadrant, which is on the left of the first quadrant, so we are going anti-clockwise or counterclockwise. So here the x are negatives and the y's are positives. And in the third quadrant, both x and y are negative, and in the fourth quadrant x is positive and the y's are negative. On the axis, one coordinate is 0. So on the x-axis, the y coordinate is 0. And on the y-axis, the x coordinate is 0. That is why when we want to write a point over here, let's say this much length is a. So what are the coordinates of this? It will be 0a. The a in this case must be negative. In the same way, if I ask you what are the coordinates of a point over here where this distance is b, so what will be the coordinates? B, 0. So over here, in the first case, it will be 0, negative a. Okay, so 0, negative a. Why? Because a is this distance. Distance is always positive. So this distance is a. So the coordinate will be 0, negative a. Now if I give you the same distance over here, that this distance is a, then the coordinates of that point will be 0a. Okay. So if we pick a point, so how many points are here in this plane? Infinitely many, right? So points can lie on the axes. They can lie somewhere in the quadrants. So if a point is on the axis, it is not in a quadrant. Okay, so on axes do not axes are not included in the quadrant. Now, if we look at our unit circle, so let's say if I have a circle over here, let's say this is unit circle. What does that mean? It means from here to here length is 1. From here to here it should be 1. From here to here it should be, which is not looking like, but this is also 1. Okay, so all these lengths will be, and then if I go, because this is the center, from the center you go to the circle radius, that is the radius, and the radius is 1. So all these lines, any line you draw from the center to the circle, its length is 1. So we say, so the points of the plane, note the points of the plane make this circle. So circle is what? It is a set of points. The definition of circle, if you don't know, is, what is a circle? Circle is a set of points which are equidistant from a fixed point. That is the definition of the circle. Now that fixed point is called the center of the circle. And the distance, fixed distance or the equal distance, so when we said equidistant, means their distance is equal. And the fixed distance is called the radius of the circle. So this is the definition of a circle. Now, some points of this plane lie on the circle. You can see that, right? So there can, now how many are they? Infinitely many. So all these points which are making the circle, all these on the circle, they are points of the plane, right? So if we are given a point, we can check whether it lies on the circle or not by what? By doing what? So remember, a point will be on the circle if it satisfies the equation of the circle. So if you have a point AB and you want to check whether it is on the circle or not, you will plug it into the equation of the circle. X squared plus y squared is equal to 1. So that your AB, so if you, in place of x you will write a, so equation is x squared plus y squared is 1, so you get a squared plus y squared, and then you, sorry, a squared plus b squared, y is b, and you will then work on it. If it is equal to 1, then yes, the point is on the circle. If it is not 1, then the point is not on the circle. Okay, so I am not saying less than 1, greater than 1. Of course, that's not equal to 1 means it might be greater than or it might be less than. So then we say the point is not on the circle. So let's see, if we are given these points and we have to check whether they lie on the circle or not. So the first one, so this is the x value, this is the y value. So I will plug it into the equation. X squared plus y squared is equal to 1. So I will start with negative 5 over 13 whole squared plus 12 over 13 whole squared, which is equal to, so 25 over 169 plus 144 over 169. So we take the common denominator, which is 169. So in the top I can just add. When I add these, on the top I am getting 169. And at the bottom I have 169. So I end up getting a 1. So what does that mean? Yes, this point is on the circle. On the unit circle. So this is how you do that. Now for the second one, again you'll plug in this equation. So we start by finding the negative 5 over 7 whole square plus negative 2 into square root of 6 over 7 whole square. Now the first gives me 25 over 49 plus, so remember, a negative value when squared gives you a positive value. So the negative is gone from here because we took the square of the negative 5 over 7, and now I'm going to square the negative 2 into square root of 6 over 7. So then square will annihilate the negative sign. So bottom is 49. What goes on the top? Now this is something you can do on a side, not like right here. It looks like it's a part of the problem. You can do on a side, maybe like a line, vertical line, and you can say scrap work, or even if you didn't say anything, it's fine. So we have to square 2 into square root of 6. So you can write 2 copies of it. 2 into square root of 6 times 2 into square root of 6. So we get 2 times 2 is 4, and square root of 6 times square root of 6 is just 6. So 4 times 6 is 24. So now common denominator is 49. 25 plus 24 is 49 over 49 equal to 1. So yes, this point is on the unit circle. Okay. So now, we were looking at points, or we were checking whether a given point lies on the unit circle or not. Now, the next question is kind of a little bit opposite of what we just did. Now, this says find the point xy on the unit circle. So it says it is telling you that xy is on the unit circle, okay, from the given information. So first one, the point with x coordinate 2/5. So it means x is 2/5. We have to find y. Y is equal to what? Such that the point lies in the fourth quadrant. Okay, point lies in the fourth quadrant. So we have to find y such that x is 2/5, the point is on the unit circle, and the point lies in the fourth quadrant. So how do we do that? Well, the only thing we have is our equation. So I will plug in the value of x in the equation, the y, because I don't know y, so it will just stay as y, and we can then figure out or find out what y actually is. What is the value of y? Okay, so I plug in the equation x square plus y square is equal to 1. So I'm going to plug it in here. So my 2/5 whole square plus y square is equal to 1. So I get 4/25 plus y square is equal to 1. What do I do next? I will subtract the 4/25 from both sides. So I end up getting y square equals 1 minus 4/25. Simplify it. Take the common denominator. So we get y square is equal to 25/25 minus 4/25. So we get 25 minus 4 whole divided by 25. So which means y square is equal to 21/25. So now what is y? So normal calculations will give us y is equal to plus minus square root of 21/25, which is equal to plus minus. Now square root of 21 I cannot simplify, so I'll just keep it like this, and the square root of 25 is 5. So this is what I'm getting, but it should be only one value. And which value will we take? Well, because we are in the fourth quadrant, and in the fourth quadrant the y coordinate is negative, so which means y point is in quadrant 4. Therefore, y is equal to negative square root of 21/5. Hence, the point is the required point is 2/5, comma, negative square root of 21/5. So this will be your answer. Okay, next example, the point with a positive x coordinate. So again we have a positive x coordinate, so x is greater than 0, and the y coordinate is negative. So again we are in the fourth quadrant. So, but we will do it the same way. This time we know y and we have to find x. In the previous example, we knew the x coordinate and we worked to find the y coordinate. This time we will be finding the opposite. Okay, we are given the y coordinate here, and then we are finding the x coordinate. Okay, let me fix this. It didn't look like 21. Okay, so now y coordinate is this, so I will plug in. I get x square plus negative square root of 5 over 5 whole squared and is equal to 1. Why can I say that? Why can I directly write it equal to 1? Because it is given that the point is on the unit circle, so it must satisfy the equation of the unit circle. So this gives me x squared plus 5 over 25 is equal to 1, or x squared plus, now you notice this simplifies to 1 over 5. Okay, going to the next step, x squared will be equal to 1 minus 1 over 5, so which means 5 minus 1 over 5, which is equal to 4 over 5. So x square is equal to 4 over 5. Now over here you can directly say x is positive. Okay, x, because it is given, right? X is greater than 0, so x will be equal to square root of 4 over 5. Or you can first say from here x is equal to plus minus square root of 4 over 5, but x is greater than 0, it is given, so x must be the positive value. But this can now be written as 2 over square root of 5. But notice here in the case of the y, we didn't have a square root in the denominator, we have the square root in the numerator. So we should do the same thing over here. We should get rid of the square root in the denominator. And how can we do that? We can do that by something called rationalization. How do we rationalize? Well, when we have numbers this simple, we will multiply by the square root of 5 on top and bottom. So, notice here, if I had something like this, instead, then I will have to rationalize this one, to get rid of this square root sign from the denominator, I would have to multiply by the conjugate of the denominator. So I would have to multiply by something like this. Okay, but we have only square root of 5. Square root of 5 is not a, I mean it doesn't have a conjugate, you can say. Okay, so now it is an irrational number, square root of 5, by the way, but it does not have a conjugate. So how do I simplify this? I multiply by square root of 5 top and bottom. So what will that give me? X is equal to, so on the top I get 2 into square root of 5, at the bottom I get just 5. So the point is the required point is, so we got what, 2 into square root of 5 over 5 comma negative square root of 5 over 5. So these are the coordinates of the point. Okay, let's see last example of this type. what is it saying now? The point with the x coordinate negative square root of 3 over 17 that lies above the x-axis, So where is the point then? The point with x coordinate negative whatever, so x is equal to negative 3 over square root of 3 over 17, and y is above the x-axis, which means y has to be greater than 0, which means we are in the second quadrant. Now, the question didn't ask us to tell which quadrant the point will be in, but there is no harm in writing that, or at least knowing. So what do we do now? We have to find the y coordinate, so we do the same thing we have been doing in the previous two parts. So plug in the equation of the circle. So x squared will be negative square root of 13 over 17 whole squared plus y squared is equal to 1, which gives you 3 over 17 square, I think, is 289. We can check in a minute. And here plus y square is equal to 1, which implies y square will be equal to 1 minus 3 over 289. So that y will square is equal to 289 minus 3 on the top, and at the bottom 289, which is equal to 286 over 289. So that y will be equal to, now y will be positive, so it will be square root of 286 over 289. Now the bottom we know is 17, so bottom is 17, but what goes on top? So square root of 286. This will not be a whole number, but we should be able to simplify it, pulling out the maximum what do you call it, the maximum perfect square in there, if there is any. So how do you figure that out? Well, you try to factorize it, write it into as its prime factors. So what does it mean to write as prime factors? What are prime numbers? I hope everyone knows. So prime numbers are numbers that are divisible by only by themselves or by 1. Okay, let me shrink this thing a little so that we have more space. Okay. So now I am going to see if I can factor out the 286. So 286 is divisible by 2. 2 is the smallest prime and it is the only even prime. Okay, 2 is an even number, so but it is also a prime number because it's divisible only by 2 and 1. Well, every number is divisible by 1. Okay, remember this. So prime numbers are those numbers which are divisible by 1, which is every number is, but what is the other property they have? That they are only divisible by themselves, no other factor. So 286 I can divide by 2, so I will be left with 143. Now I don't think that 143 is divisible by anything. Actually 143 is a prime number. You can check division by 2. Think of it. Is it divisible by 2? No. Why? Because which numbers are divisible by 2? The ones which have the last digit on the right last digit a 0 or a multiple of 2. So this is 3, which is not a multiple of 2, not divisible by 2. What about 3? To be divisible by 3, you add up the digits of the number. So number is 143. So 1 plus 4 plus 3, we get 8. Now if you get a number over here which is divisible by 3, then this number will be divisible by 3. That is the kind of a neat trick to check. So we see that we are getting 8. 8 is not divisible by 3, so the number is not divisible by 3. Okay, I figure out one divisor of this, but let's see. Yeah, I think there is one divisor. Yeah, okay, we will come there. So next prime number is, so we have 2, 3, and the next one is 5. So it's not divisible by 5. We don't have to divide. We just have to look at the last digit again. If the digit is 0 or 5, then it will be divisible by 5, since the last digit is 3. So 143 is not divisible by 5. Next is 7. So 7, there is kind of no rule or no trick. So you basically have to check. So if you, it's obvious, we have 143. If you divide by 7, 7 2s are 14, nothing left here. You bring down the 3 and you cannot divide. It doesn't go. So you have a remainder. So which means it is not divisible by 7. So 7 is not a factor of this number. What is the next number? What is the next prime number? If you I hope nobody said 9, because 9 is not a prime number. Why? Because 9 is divisible by 3. So it is divisible by 1, 9 and 3. So it has one extra divisor or factor, which makes it non-prime. So the next prime number will be 11. And if we divide 143 by 11, it does get divided. So 11 here. So 11 ones are 11. Left with 3. Bring the other 3 and we get 3. 11 3 times 33. So we can divide it into 11 into 13. Now, once we have done that, then we say we can write our number 286. We can write it as, so 286 can be written as, these are the factors. These are the what we call the prime factors. So we can write it as 2 times 11 times 13. Now no factor is repeating. Can you see that? No factor is repeating here. So when we take the square root, we cannot bring anything out of the square root, because things come out of the square root if they are paired. If you have 2 of them inside the square root. So if I do square root of 286, it will be square root of 2 into 11 into 13, because nothing is repeating. I cannot take anything out. So the 286 will remain as it is. So this will be your value of y. So the point is, the point is, or the required point is negative square root of 3 over 17, comma, square root of 286 over 17. Okay. So this is how you find the points which are on the unit circle. Okay, I'll stop here. Next portion of the section 5.1 in the second video.